Our lesson for today will be looking at physics. The level that we'll be focusing on today is level 3, which is grade 12. The topic is momentum. We are still busy with practice questions. This is lesson 104. Let us start. As usual, practice questions are meant to make you master a particular chapter. So as usual, just make sure you pause the video the moment you see the question. Try to work it out and play the video after working out the questions to verify your answer. So we can see that this question is well presented because we do have a statement and also a diagram, picture form of the statement. Now looking at the statement, it says, or the scenario says, the diagram below shows a bullet of mass m1. So we can say the mass is not yet given. Striking a block of mass 2, second mass, it's also not given. Lying stationary. So like I said, just make sure the picture and the scenario, the information, it's fully filled on the picture. So we can say the velocity here is 0 meters per second because they say it is stationary. You can see the velocity of the bullet, it's 300 meters per second, but we'll get to that. So it's saying striking a block of mass m2 lying stationary on a horizontal frictionless surface. So there's no friction on the surface. The bullet strikes the block with a velocity of 300 meters per second. You can see the velocity. Passes through the block and emerges from the block with a velocity of 120 meters per second. So it gets in and out with this velocity. The block moves at 1.8 meters per second in the original direction of the bullet. So after collision, the block also moves. Now we have a substatement or subscenario here. It says it is observed that the kinetic energy of the bullet block system decreases by 752.76 joules. Now, during the discussions with my fellow students or my fellow learners, this statement, it was confusing them. We have a bullet. It was before emerging to the block. When it strikes the block, or we can say before it strikes the block, it had a particular kinetic energy. We don't know that kinetic energy, and also it is not that important to know that particular kinetic energy. But after leaving the block, we know that the kinetic energy, whatever kinetic energy it had, it decreased by 752.76 joules. Let's say, for example, before it collides with the block, it had about 900 joules. After leaving, we are going to have 900 joules minus this. So it has decreased by this. But the problem is we don't know the kinetic energy before. And it's also okay. It will not actually stop us from calculating it. So we can say before, let us just remove this equal sign. Before it had this kinetic energy. And then after collision, we know that the kinetic energy it had minus this one, it's the one that it has, which is our new kinetic energy, of which it's what I've done here as an example. This is our EK, And then our new EK will just take the original EK, or the initial EK, minus this one. So this is what is actually happening here. So let us start with 4.1. 4.1 says, the question is the collision between the bullet and the block elastic or inelastic? Give a reason for the answer. We know that for the system to be elastic, the energy should be conserved. Inelastic, the energy is not conserved. So as you can check here, when we say the energy is conserved, it means it remains the same before and after. Before it had this, after it has decreased. So you can see that EK before it's not equals to EK after. Then in this case we can see that kinetic energy is not conserved. So our answer here would be inelastic. The reason, kinetic energy is not conserved. Then you'll get a mark for this and the mark for the reason. We continue to the next question. Use the principle of conservation of linear momentum to calculate the mass of the block in terms of the mass of the bullet. So we should understand that in terms of the mass, this simply means that our answer will not be a numerical figure, since we have M1, M2. So our answer will have M1, M2. So it's 4.2. The equation says the sum can say initially or before, it's equals to the sum after or final. Then we can go ahead, M1 V1I plus M2 V2I equals to, our situation here, it's not a stick together, so even after collision the two objects separated. So the first object will have its mass and its final velocity. Why do I keep on putting I? Plus the second one will also have its own quantities. We are going to consider the bullet as 1, the block as 2. Let us go ahead and substitute. M1, we don't have the mass, so we are going to put M1, but you know the initial velocity, it's 300 meters per second. And by the way, what is very important, we take right as positive, left as negative, but we can see that the directions we have in both situations, before and after, it's the positive direction, plus the mass of the block, it's M2, and then the velocity, it was stationary, so you're going to put 0. The mass remains the same, we have M1, but you know the final velocity is 120, still on the positive direction, Then we have the second mass as m2. Then we know that it travels at 1.8 meters per second to the right positive direction. This will result into 0. So here we have 300 m1 equals to 120 m1 plus 1.8 m2. Now we have to group the like terms. We're going to take this to the other side. Then we have 300 m1 minus 120 m1. It's equals to 1.8 m2. 300 minus 120, we have 180 m1. It's equals to 1.8 m2. Then we can divide both sides by 1.8. If let's say we want to express our final answer as m2, the subject of the formula, then we are going to get m2, because this will get rid of this. Actually, it will result into 1 multiplied by m2, we get m2. We have 180 divided by 1.8, we have 100 m1. This is our answer. Or from here, from this step, instead of dividing by 1.8, we can make m1 the subject of the formula. Let us do so. It's another option. So we have 180 m1, it's equals to 1.8 m2. We divide both sides by 180. And then we have m1 equals to, we are going to get 0.01 m2. This is also another answer. It's also acceptable, you'll get full marks. So looking at mark allocation, you are going to get the first mark, here, substitution from both sides, and the last mark here. I hope you got this one correct. Let's continue to the last question. The question 4.3 says calculate the mass of the block in kilograms. Now I have to mention that when I first read this, I actually considered or focused only on bullet, but it's actually bullet block system. It's bullet block system decreasing by this. So going back here, not necessarily kinetic energy of the bullet, but is the bullet block. Because if we're only focusing on the bullet, we can say after collision it has lost this. But is the bullet block, meaning that the moment it impacts inside this block, that is when we have this. This situation, it's where we have EK minus 752,75 joules. Because here we no longer have bullet block system, we have two objects. But looking at a bullet block system, it's when the bullet, it is inside the block. That is when we have this. So the next question, we can use the conservation of mechanical energy since there is no friction. So we can say it's 4.3. EK of the bullet we can actually rearrange the equation quickly, because we don't have a situation whereby we have the top and the bottom. So in this case, we can just rearrange the equation and not write the mechanical energy, the potential energy. We can just focus on the kinetic energies. So it's EK of the bullet, then this is for the block, this is before, and then EK of the bullet after plus EK of the block. Let me quickly explain this. We know that conservation of mechanical energy says EK plus EP it's equals to EK plus EP. Now I said let us not focus on the potentials because our height is 0. Remember that we are looking at the block, the bullet block system, this system here. Looking at the height, it's actually 0. So in this case we can just say we cancel out the EPs since we know that our heights would be 0, and then we have EK equals to EK. Now it's not EK of the bullet or EK of the block, but it's EK of bullet block system. So we have to expand this to say the EK of the bullet. We can even put it inside the brackets plus the EK of the block. It's equals to, we do the very same thing here, EK of the bullet plus EK of the block. This is what I actually meant with this equation. Then we know very well that EK is equals to half mv squared. We have half mv for the block, half mv I squared, it's equals to, you can just do the very same thing here, but it's the final velocities. So we should understand that for this, it's when we have that bullet block system. That is where EK minus 752,76. This situation here. The mass of the bullet, it's m1. The velocity, it's 300 squared plus half, we have m2, but we know that it was stationary, so we put 0, it's equals to, I will explain this part shortly. Let me continue substituting. We have m1, vf, we know that it travels with 120 squared plus half, we have the mass as m2, then the velocity as 1.8 squared, and then this we know that it will be 0. Now let us go back to this equation here. This is a bullet block system expanded. This is the expansion, the expanded version of this. But we say that EK has lost or decreased by 752.76. So here we can put minus 752.76. It means that whatever that we have here, we have to minus it with 752.76. Let's do that here. So we have half m1 300 squared plus 0 minus 752.76 equals to, well, we can start simplifying. It's half multiplied by 300 squared. We are going to get, let us go ahead and we're going to get 45,000 m1. Then let us do the very same thing here. We have half multiplied by 120 squared. We get 7,200 m1, and then we have plus 1.62 m2. Okay, and then when we continue simplifying, we are going to get, actually let us group the like terms. We take it to the other side. We have 45,000 m1 minus 7,200 m1. It's equals to 1.62 m2. Actually, there is a mistake here. I should put this minus 752.76 equals to 1.62 m2. And then from here we can simplify this. 45,000 m1 minus 7,200, we get 37,800 m1 minus 752.76, 1.62 m2. Now we are looking for m2. We are looking for this, but you can see that we also have this m1. But we know that from the previous question, m1 is equals to this. So where we see m1, we can substitute by this. You can see that this is actually a simultaneous equation. So let us go ahead and substitute. This is our m1. So we have 37,800. We substitute it with 0.01 m2 minus our lost kinetic energy 1.62 m2. Then from here we can multiply this. We get 378 m2 minus 752.76 is equals to 1.62 m2. We can double transpose, take this to the other side, take this to the side. We have 378 m2 minus 1.62 m2 is equals to 752.76. We have 376.38 m2 equals to 752.76. We divide both sides by this number. We get This will result into 1 multiplied by m2, we get m2, and then the answer, this divided by this, will get exactly 2 kg. There might be another way, but this is the way that I thought of to answer this question. And actually this was supposed to be allocated 5 marks instead of 4. Looking at mark allocation, you get a mark for substitution here and substitution here, and from this step you can also include this part here, then you'll get full marks there. Then you also get 1 here and 1 here, and then solving the mathematical operations, there's no mark for that until you get the final mark here at the final answer. Well, I hope you do understand. That's it for this lesson video. This is Rahula SJ. Thank you very much.